Hello, everyone, and welcome to the Solid Waste Authority of Palm Beach County's virtual programs. My name is Mary, and I'm one of the education specialists. Today, we have Kyle, the operations manager for Renewable Energy Facility 2, taking us behind the scenes to explore a bit. Now, if you notice, the stack behind me has no big plumes of dark smoke coming out, right? Even though we're burning approximately 3,000 tons of waste a day in this building. That's because of our state-of-the-art pollution control systems. Renewable Energy Facility 2 opened in 2015, and it's the greenest waste-to-energy facility in North America. Now I'm going to turn it over to Kyle, who's going to explain exactly how all this works. Hope you enjoy watching, and if you have any questions during the video, please feel free to type them in the comment section or send us an email at education@swa.org.
Hey everybody, Kyle here again from SWA, Rescue Facility, Renewable Energy Facility number 2. Today we're talking about environmental equipment. So we will go in the office, we'll look at some diagrams. I will explain in some kind of general terms what equipment we have and what it's for. There are some unwanted waste products that are generated when we burn and combust garbage, and those emissions should be dealt with before they go into the environment to make sure that we're not polluting. And today we'll talk about all that equipment we use to make sure that what we put out into the atmosphere is not harmful to the environment. So quickly, if we take a look behind me, right, behind me now, all of this equipment is our incinerators. So those are our combustion chambers, our boilers. That's where we make that 2,500 degree fireball, and we absorb the heat to generate steam and make electricity. And then if we look in this direction, everything behind me now, about half of our facility, is to deal with the byproducts of combustion waste, right? So we'll go ahead, we'll speak about some of this equipment, and then we'll go look at it in closer detail. All right, thanks.
Hey guys, Kyle here again. Here's a diagram that we can use to explain some of the environmental equipment we have. So this is a side view diagram of our whole facility, starting with our funnel. Over here would be the pit, overhead crane, which brings in the trash, goes down into our hopper or funnel, where it's gravity fed down into our boiler. And then in this general area here, we have our 2,500 degree fireball where we're combusting waste. We bring air from the tipping floor in underneath to provide the oxygen necessary for the fire. And then that heat and flue gas makes its way through these different passes and turns through our boiler, all while generating, we're absorbing the heat from that flue gas, from the hot air being generated from the fire, through the metal piping in the walls, which is then boiling water and making electricity. All of the ash that's left over comes out here and is collected into our ash system where we can bring it to landfill, safely landfill it. If we follow the path of flue gas, we can see that it goes through here. Again, we're collecting the heat from it and eventually going through this portion of our equipment. From this point on, all of this equipment is environmental. It's all there to deal with what pollutants are generated when you burn trash. So one of the first things we do is we inject a powder activated carbon, which binds with mercury, so that we don't release that into the atmosphere and it can be safely landfilled. After that, it goes into our SDA, which is basically a big cylinder, and inside there is a fast spinning nozzle, kind of like a fancy sprinkler system. And what it does is it sprays in a lime slurry mixture, which is a basic element. So it has a basic pH. And the acid gases, which are what's responsible for making acid rain, when you take something basic and acidic and you put them together, they neutralize each other. And that's what we're trying to do in here. So we're lowering the temperature of the flue gas. We're injecting lime slurry to neutralize acid gases. And then from that point on, we're moving in and we go into our bag house. So this whole thing here is like a giant oversized vacuum cleaner. It has 8 compartments. Each compartment has in total we have over 1,700 of these bags, and we'll show you a bag later on in another video. And those bags are 2 stories tall, and they look like big cylinders. So the air gets pushed through them, similar to how a vacuum cleaner works. So any particulate that's in the air would get trapped by the filter and the clean air then passes through and continues on through the system. As enough ash is generated and collected on the sides of those bags, they get kind of plugged up and the air can't push through as easily, so it creates a differential pressure, and we can measure that, and when it gets too high we initiate a clean, so it will reverse the airflow, and we'll fire sonic horns, which are like giant subwoofers, and that vibration from the noise helps shake the ash off, where it goes down into these individual hoppers and again joins the rest of the ash. After that, it goes through some ductwork and ends up into this section over here, if you can imagine the connection. And this is our catalyst system, which is unique to our facility. We're the only waste energy facility in the country to utilize this. Very good, newer technology. It helps make us the cleanest waste energy facility in the country. And what we do is we spray in an ammonia gas, which mixes with the flue gas and goes through a catalyst, which is a special kind of metal in the shape of a honeycomb, vanadium metal, and some chemical reactions take place. And what we do is we break nitrogen oxides, which are dangerous to the environment, and we break them down into water and nitrogen, which are naturally occurring and not harmful to the environment. So after it goes through there, we go through some series of heat exchangers just to try to recover some leftover heat and make the boiler a little bit more efficient. And then the last step we go through is our CIMS, or Continuous Emissions Monitoring System, which is a computer which takes a smell, so to speak, of the air that we're putting out of our stack 24/7 and make sure that we're not polluting. And that gets checked by a third party in the Department of Environmental Protection to make sure that all of this stuff is working properly. And again, just up here in the corner, you can see that we do have the same exact setup 3 times. So 3 boilers, which means we need 3 sets of environmental equipment, and they're all identical. Great. So we'll go out in the field and we'll look at some of these things in person and see what they look like in real life. Thanks.
All right, guys, so here's our chemical storage area for the facility. So as I said, we use some chemical reactions to take place to address some of the environmental concerns here. So first up here, we've got 2 silos, as you can see, very tall, that store lime pebble, and we then generate it into a lime slurry. So the top portion of these silos are filled with lime pebble, lime rock that looks kind of like gravel, and then about midway up where that platform is, we have a piece of machinery called a slaker, which takes that lime pebble, mixes it with water, basically agitates it, stirring it, and creating lime slurry. So we have a chemical reaction taking place to create lime slurry. And the bottom of these are lime slurry, which is a liquid now, storage area where we can then use this, pipe it up to those SCAs we looked at earlier, spray it in, and knock out those acid gases. Next up over here, this is our carbon silo. So this is where we keep our powder activated carbon, and then we use some air compressors over here, and we actually blow that up to the top portion right before the SDA, where it can be spread evenly across the whole stream of flue gas and bind with any mercury that would be in there. And then last up here is our liquid ammonia tank, where we take that, eventually we heat it up into a gas state, and then spray that into the boiler, mixing with the flue gases, and eventually making its way through our catalyst and reducing nitric oxide emissions. Okay, guys, so first thing up on the list, we're going to talk about our SDA. That stands for Spray Dry Absorber. And this is that long cylinder I spoke about, and that goes all the way down to the floor, and it's got some turning vanes in there that create a twisting action. If we look over here again, here's all of our boiler and combustion equipment. Here is the ductwork where those flue gases that are generated come in. We inject powder activated carbon to mix with mercury. After that, it goes into our SDA, in through the top here. It spirals around in a big circle into the bottom of this cone, where there is one of these rotary atomizers, which spins down here at the bottom. This portion spins very, very quickly, spitting out the slurry, lime slurry, and breaking it into very, very small droplets so that we can have the most surface area to have the best chemical reaction. Again, we're taking a basic lime slurry and mixing it to combust with the acid gases to remove them and neutralize them. After that, it goes into the SCA vessel, which again is this big cylinder all the way down to the floor, and then cools the flue gases a little bit, and then moves on to our fabric filter. And we'll talk about that next. Okay, so here is our fabric filter or bag house. As you can see, there's 4 compartments on this side, 4 compartments on this side for a total of 8 compartments. And what we do is inside, behind this door, we have a total on each of these 1,700 plus fabric filter bags. So you can think of them, and I'll show you a video of them shortly, but they're 2 stories tall. They hang from the top of this all the way to the bottom. And what we do is we force the air to go through those bags, acting as a filter membrane, taking all of the particulate matter out of the combustion gases. So as the flue gas comes through, there is small particles of ash that are still being brought through the air from the current of the air moving. And that's what gives smoke its color or opacity. If we are able to take all the ash out of that hot air, then it would be basically invisible, right? It would just look like normal air, just be hot. And that's what we're doing at this point. So we're taking all of that particulate matter out of the air to make sure that we're not blowing ash out into the atmosphere. And these are fully automated cleaning cycles. So as the bag gets fouled, a lot of ash gets trapped in there. The differential pressure will increase because it will be harder for the air to move through the filter as it's dirty. And that will will generate an automatic clean where we reverse the airflow, and we'll have some sonic horns fire, like big subwoofers, making vibration, sonic waves that will knock the ash off, clean those bags, and we can repeat that cycle over and over and over. All right? Great. Thank you.
All right, so here's an example of one of our fabric filter bags. As you can see, we have 2 sides, and it's basically a cylinder in shape. One side of it is sewn completely shut, and the other side is open and held open with a spring mouth. And the purpose of this is to allow this bag to inflate, similar to like a balloon, or like one of those wacky, wavy, inflatable arm man that you see at used car sales lots. So what happens is, basically, we force the air to go through this bag. Right? And then this whole bag, the whole material, becomes one big filter. So as the flue gas gets pushed through, these tiny little pores, very, very small, trap all of the particulate or all of the ash that's in the air. And then that allows us to put clean air out into the environment. Again, each one of these units has about 1,700 plus bags, and they're about 2 stories tall each.
Hey guys, Kyle here again. We did a lot of talk about our emissions. So I just wanted to give you a video here showing our stack, and you can see coming out of the top what would typically be called a smokestack at most power plants. Here is just a stack. Basically what's leaving is basically hot air, right? We do a very good job of cleaning up all the materials and all the byproducts from combusting waste, and here's a good visual representation of that. Nice beautiful day here in South Florida. Thank you.
Thank you again for watching, and hope you learned something about our Renewable Energy Facility 2's environmental controls. Be sure to check our Facebook or website at swa.org/education to see the rest of this week's educational programs. Have a great day.